So we've covered the theory behind logarithmic and exponential graph transformations. What I'm going to do in this video, I'm going to set you a few questions on this topic. I want you to go away and have a crack at these questions, come back and then check your answer against the solutions which follow in this video. So here they are. I want you to sketch the following four graphs. First one, log to the base 3 of x plus y. Second one, y equals log to the base 2 of a half x plus 1. Third one, y equals 2 times 3 to the power of 3x. And the fourth one, y equals negative 2 to the power of x plus 1, take away 1. What I want you to do is pause the video now and have a crack at these, then come back and check your solutions. So the first video, y equals log to the base 3 of x plus 1. So think back to what the basic graph of log to the base anything would look like. So it would come up from the bottom here, cut the x-axis and go over here. It would always cut the x-axis at the point 1, and it would always have a coordinate here, a comma 1, where a came from the base of the logarithm. So this one here would cut at 1 and have the point 3 comma 1 because of the base there. However, x plus 1 here, remember what that does to the graph. That shifts the graph in the x direction, and because it's a plus 1, remember x does the opposite to what you want. It shifts it left by 1, so essentially think of it as take away 1 rather than plus 1. So the point that was here at 1 shifts to the origin, so it's going to cut there, and the point that was here at 3 comma 1 shifts down to 2 comma 1. So my graph still has the same general shape, except I'm now going to cut at the origin. We'll mark that with a 0, and I'm now going to have the point 2 comma 1 there. Now, one other thing you can mark on here, we know it's never going to cross the y-axis originally. This is going to shift down 1 as well. So you can imagine going to negative 1 and drawing a line going all the way down there. What this means is that I can continue the graph all the way down to negative infinity in the y direction, and it will never cross this line in x. Remember, you can't go below the y-axis for a normal logarithmic curve because it doesn't exist. You can't take the logarithm of a negative number, so it won't exist beyond the y-axis in x. This line just shifts down here for negative 1 because now I can get to a point where I can get everything down to negative 1, but if I start at negative 1 and go beyond, I start taking logarithms of negative numbers. So the graph looks like that. One key thing, remember, don't forget to write its name. So y equals log to the base 3 of x plus 1. Make sure you name it. Second curve, y equals log to the base 2 of a half x plus 1. So again, this curve here, think of the basics. It would cut the x-axis at 1, and because it's log to the base 2, it would have a point 2 comma 1. So focus on those points when we're looking at the transformation. Now, first thing we look at is how it transforms in x. So a half x, remember that stretches x. So think of it, if we divide at that point, again, x does the opposite to what we want. It'll stretch it in x. So our point that was at 2 comma 1 will now stretch out to 4 comma 1. Our x-axis intercept, which was at 1, stretches up to 2. So we've got our two key points there. We know where they've gone to for that transformation. We then look at the second part, the plus 1. Now this is going to affect the y direction because it's not partnered with the x. This will shift everything up by 1. So my graph is still going to have the same general shape for a logarithm. It just means that the point that was here, which we knew was at 2 comma 0, that now shifts up and it goes to 2 comma 1. And my point which was here, which had transformed and moved to 4 comma 1, shifts up by 1, and that now goes to 4 comma 2. And again, don't forget to name it at the end. So y equals log to the base 2 of a half x plus 1. We've marked on the key points of interest and the key bits of information we know. We've sketched the graph properly. Third one, y equals 2 times 3 to the power of 3x. Now this is the exponential style curve. So this one, instead of coming up from down there, comes up this direction here. So it comes along this way and up to infinity in the y direction. So we have to figure out the transformations first. So again, we look at the x direction first. So I've got 3x here. Now that isn't going to affect the intercept. It's still going to cut at 1 here. But remember, we always get a point at 1 comma a. Alright, so we always get a point at 1, a. So in this case it would be 1, 3 because it depends on what your exponent, i.e. the base part is. So in this case our point was originally 1, 3, but remember 3x will squash the graph in the x direction. So it'll take 1, it'll divide it by 3, and that point will move to a third, 3. The second transformation we have to then look at is the 2 times. So what this does is it multiplies everything in the graph by 2 and stretches it. So our point that was at 0, 1 will now stretch up to 0, 2. And all of our y values for this will stretch up. So y value that was at 1/3, 3 will now stretch up and go to 1/3, 6. Now a key thing to remember as well, even though we're getting closer and closer to the x-axis here, we know we never crossed it originally. Even when we multiply it by 2, we'll still never cross it. So it'll still continue on like that. And it'll still have the same general shape. It'll still go off there. But as we said, our y-intercept is now stretched up to 2. And our other point that we were interested in, that was originally at 1, 3, remember that's been squashed in x, so it's at a third, and then stretched in y by 2, by a factor of 2, so it goes to 1/3, 6. And again, same as we've highlighted in the other examples, name it. So y equals 2 times 3 to the power of 3x. Final one we need to look at is this one. Y equals -2 times x to the power of x plus 1, take away 1. So we need to look at each of the different transformations that this will go through one by one. So first one is the negative in front of the 2. Now that flips it in the x-axis. So our curve originally went off up that direction. In this case, it's flipped in the x-axis, so it goes down the way. We then look at our key point here. So x plus 1 shifts everything to the left by 1. So originally we had a point here that was at 1, 2. That would go to 1, -2, but then shift left by 1. So it would be at 0, 2 here. Our point that was on the axis here went from 1 to -1, and it will then shift back by 1. So it will then go to -1, -1. Our final transformation is the -1 here. Well, that affects the y direction and shifts the whole graph down by 1. So it's going to shift the whole graph down by 1. It's going to look something like that. Now our original y-axis cut, again, remember it was 1. First transformation flipped it to -1. Second shifted it back 1, but this third one here will shift it down 1 again. So this is going to be at -1 from the x direction, -2. And our point that was here at 1, 2 shifted down to 1, -2, then shifted back and then shifted down. So it's telling me my y-axis intercept is now at -3. Now another key thing to note that we can mark on, remember the whole graph is shifted down 1, and originally we couldn't cross the x-axis. That gave us a negative value, we couldn't do it, wasn't allowed. So this whole thing, because of this -1, shifts down as well. So we can mark on that discontinuity and make sure it's known to be at -1 now. So it's never going to cross that -1 line there. Alright, it's never going to give us that. It's never going to work. So, there you go. Don't forget, again, name it. So y equals -2 to the power of x plus 1, take away 1. That's the name of the graph we've just sketched. So some interesting transformations and things in it. Slightly more complex than some of this trigonometry or just general polynomial ones. So it's a good thing to focus on. So hope that went well for you. I'll see you in class to answer any questions.